In this video, we want to use the definition of a parabola to derive the equation of a parabola in vertex form. So remember, first of all, that the equation of a parabola in vertex form is going to be given by y equals 1 over 4p times x minus h squared plus k. So that's the equation we want to get at the end. The definition of a parabola is all of the points that are equidistant from a set line, the directrix, and a focus. So this and this should be equal distance. So what we're going to do to make this happen, we're going to pick a random point on our parabola right here, and we'll call it x, comma, y. So here, this value is going to be x, and in fact that value is not the one we're looking for. This value is going to have an x value of x and a y value of k minus p, since it's on the directrix. This distance, on the other hand, will just go from our point xy to h, k plus p. These must be equidistant per the definition of a parabola. So first we'll recall the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So with that knowledge, we can set up a statement of equality. The distance from h, k plus p to xy, that is to say, this distance, must be equal to the distance from xy to x, k minus p, this distance. So we can set those up into two distance formula statements. So if we set xy as 0.2, we'd have x minus h plus y minus k, and that should be in parentheses, plus p. And both of these are, of course, squared. And that would have to equal the square root. And here for the second distance, we have x minus x squared plus y minus k minus p squared. So now we have something we can work with. We could square both sides, get rid of those, and we'd have x minus h squared plus y minus k minus p squared, just simplifying a bit, would be equal to, over here we'll have x minus x is 0, and 0 squared is 0, plus y minus k plus p squared. So of course, 0 disappears entirely. We won't include that in the next line, it's not necessary. We can leave x minus h squared in that form because we know we want to get that when we look back here. X minus h squared is one of the things we're looking for. We are going to need to FOIL out these. So I'm going to use a box method to demonstrate that. So this Punnett square represents multiplication. You might also hear it referred to as a generic rectangle. So I'm multiplying y times y, which gives me y squared. Y times negative k gives me negative y k. Y times negative p gives me negative y p. Y times negative k gives me another negative y k. negative k times negative k gives me positive k squared. Negative p times k, negative k gives me positive kp. And we just keep multiplying. Y times negative p is negative yp. K times negative p is kp. And then negative p times negative p is p squared. We do have some like terms here. These are like terms. These are like terms. And these are like terms. We can come back and rewrite that into our original problem. Y squared minus 2yk minus 2yp plus k squared plus 2kp plus p squared. So you should end up with something like that. So at this point, this is a good time to pause the video and double check that we match on what we show here. So now we need to move like terms. But before we do, there's some things that we can cancel out. If you subtract y squared from both sides, you find that it cancels out because they're both positive y squared. The same thing will be true for yk or ky. If you add 2yk here, and that's just the opposite order, those cancel out. Add 2yk here, and these cancel out. Same thing is true for k squared. And the same thing for p squared. So now let's take a moment and rewrite our expression without those values. So now we want to move all terms containing a p to one side. So let's move those away from the x minus h squared. In fact, we're going to do that and then we're going to switch the sides. So we're going to have x minus h squared, leave some space there, add 2yp to both sides. So that's going to cross out here, but over here we get 4yp, and subtract 2kp from both sides. So it's going to minus 4kp. And before we do anything else, I'm going to switch those sides. So we're just rewriting it so that the left and right side have swapped. That will put it in the form that we expect to see. So now we're going to factor out from the left side 4p. So we get y minus k is what's going to remain. X minus h all squared. Now we divide everything by 4p. These cross out on the left side. So we get y minus k is equal to, Dividing by 4p is the same as multiplying by 1 over 4p. So now you can see we're getting very, very close to our anticipated form. Our final step is adding k to both sides. As we add k, y is finally isolated, and now we have our form as expected. This is the vertex form of a parabola. P is the distance from the vertex to, we can go see that here, the focus. And we know that because all we did to get our focus here is added P to K. It's also the distance from the vertex to the directrix, because all we did to change the y value here was subtracted P.